You lean under a desk, guide a cable from the router into a laptop, hear a small click, and stop thinking about it. The connection works. The internet arrives. The cable disappears into the background of life. That is exactly what makes it interesting. We use these wires constantly, call them network cables or Ethernet cables almost interchangeably, and rarely ask what they actually are. Are those names really the same thing? Why do some say Cat5e, Cat6, or Cat7? And if this is just a simple wire, why does it need such careful design for data to travel quickly, cleanly, and reliably through it? The more ordinary the cable looks, the easier it is to miss how much thought has been packed into it. What exactly are we holding when we hold an internet cable? Let's get into it right here on Secrets of Simple Things. A network cable is the category. Ethernet is one type inside it. A network cable is the larger idea. It is not the name of one exact design, but the general category for any cable that lets devices exchange data. If it connects a laptop to a router, links computers across an office, carries information between servers, or joins equipment inside a data center, it belongs to that wider family. Ethernet cable is narrower. It refers to a cable used for Ethernet, and Ethernet is not simply a product label. It is a standardized system for wired communication, a set of rules that defines how data is formatted, transmitted, and received, so devices can reliably understand one another. That changes the meaning of the object. Network cable describes the function. Ethernet cable describes one specific technological member inside that function. So every Ethernet cable is a network cable, but not every network cable is an Ethernet cable. The difference sounds technical, but it reveals something deeper. Sometimes what seems like the name of a familiar object turns out to be the name of one successful solution inside a much larger family of solutions. That sounds like a small distinction, but it matters because Ethernet became so successful that its specific name slowly began to feel like the default name. How Ethernet became the language of wired connection. Ethernet emerged at Xerox PARC in the 1970s, but its importance was never just that it arrived early. What made it powerful was standardization. It gave computers a shared way to communicate over wires instead of forcing every machine and system to behave like an isolated island. As Ethernet improved, it became faster, steadier, and more dependable. Over time, it moved from being one technical solution into the dominant foundation of wired networking. Homes used it, offices used it, institutions built around it. And once a technology becomes the thing most people meet most often, its name starts drifting away from technical precision and toward ordinary language. Stores and online listings helped reinforce that drift. Sellers usually say Ethernet cable rather than something more technical and less familiar because buyers recognize it more quickly. Little by little, the label that once referred to one standard began to feel like the name of the cable itself. That is why people blur the terms. It is not usually carelessness. It is what happens when one technology becomes so common that its proper name starts spilling into the role of a generic one. But Ethernet did not always travel through the kind of cable most people picture today. Thus, the cable had to change before it could become ordinary. The cable people imagine now is slim, flexible, and plain enough to vanish behind furniture. Early Ethernet did not look like that. It relied on coaxial cable, a thicker, bulkier line that was harder to manage and less convenient to install at scale. It worked, but it did not yet have the physical ease that helps a technology spread quietly into everyday life. As networking expanded, the cable had to evolve with it. Twisted pair wiring gradually replaced those older coaxial lines, and that shift mattered for practical reasons as much as technical ones. Twisted pair cables were lighter, cheaper, and easier to route through walls, offices, and homes. They suited mass deployment far better. That change is easy to overlook because it does not sound dramatic, but it says something important about how ordinary objects come into being. Progress does not only happen inside the signal, it also happens in weight, flexibility, cost, and convenience. A thing becomes normal not because it was simple from the start, but because it was refined until living with it stopped feeling difficult. The familiar shape of the modern cable is not an accident. It is the result of repeated decisions about what people could afford, install, and tolerate in real spaces. And once that cable became common, another layer of complexity appeared. Cables that looked almost identical were no longer doing the same job equally well. Why one familiar cable comes in different levels. Cables like Cat5e, Cat6, and Cat7 can look like forgettable product codes, but they are really markers of performance. They tell you that two cables with nearly the same appearance may differ in speed, consistency, and how well they handle demanding conditions. That difference reflects a bigger change in daily life. Ethernet once ran at speeds measured in megabits per second. Later, gigabit Ethernet became normal, and higher performance environments kept pushing beyond that. More devices, larger files, constant streaming, cloud services, and heavier traffic all increased the burden carried by a simple-looking wire. So the interesting part is not the category number itself. It is the fact that a cable so ordinary had to keep evolving because ordinary life kept asking more of it. A quiet object on the floor now carries a level of speed and reliability that earlier networks never had to support. But speed alone is not enough. A cable also has to protect the data from the world around it. Inside the cable, order is being protected from noise. One of the smartest things about an Ethernet cable is hidden inside it. The copper conductors are arranged as twisted pairs rather than straight lines running neatly beside one another. That twist is not decorative. It helps reduce interference, cutting down the electrical noise that can distort a signal as data moves through the cable. That matters because the modern world is loud in ways we cannot see. Power lines, nearby electronics, wireless signals, and other sources of electromagnetic interference create a messy background. A cable can look perfectly ordinary on the outside and still fail to perform well if it cannot resist that invisible disruption. Ethernet works so reliably, in part because the cable's internal structure was designed for exactly that problem. Higher categories may add more protection through shielding, helping preserve signal quality even in more demanding environments. So what appears to be a cheap, quiet household accessory is actually performing a delicate task. It has to move data quickly, keep the signal clean, and stay dependable in rooms filled with invisible noise. That is the hidden elegance here. The more familiar a tool becomes, the easier it is to underestimate the intelligence hidden inside its design. A cable that seems passive is actually maintaining order while surrounded by interference. And once we see how much engineering is packed into Ethernet, the larger category becomes easier to understand too. Not all network cables move data the same way. Ethernet may dominate daily wired networking, but it does not exhaust the meaning of network cable. The broader category includes other ways of carrying data, each suited to different problems. Fiber optic cable, for example, sends information as light rather than electricity. That lets it move data extremely quickly over long distances with very little signal loss, which is why it matters so much in larger infrastructure. Coaxial cable belongs in the category too. Today, it is more closely associated with television and some internet connections, but it still qualifies because it still carries data between devices. And the category continues to expand. New designs, new materials, and even hybrid systems can be used when one type of cable alone is not the best answer. Different cables exist because connection is not one single challenge. Distance, speed, interference, environment, and scale all change what the best solution looks like. That is the real point. Network cable is the umbrella. Ethernet is one especially successful branch inside it. So, in everyday life, when does this distinction actually matter? Precision matters more in some contexts than others. For most people at home, the distinction changes very little. If you need to connect a computer, router, console, or smart TV, asking for an Ethernet cable will usually get you exactly what you need. In that setting, the everyday habit is close enough to reality to work. But in IT, infrastructure planning, business networks, and data centers, the broader term matters more. There, Network cable is not one obvious thing. It is a larger category that includes different technologies, materials, and use cases, and choosing correctly affects speed, distance, reliability, and cost. So this is not really about ordinary people using the wrong word. It is about precision becoming more valuable as the system grows more complex, and that is what makes this such a good, simple thing. The distinction is small, but the system behind it is enormous. A cable that carries more than data. On the surface, the difference between a network cable and an Ethernet cable can sound like nothing more than a naming detail. But the closer you look, the more that small distinction opens into a bigger story. Behind it are decades of standardization, changes in the cable's physical form, internal structures built to resist interference, rising performance demands, and a world that keeps asking more from every connection. So the next time you plug in a cable and hear that small click, it may not feel quite as invisible as before. What looks like a simple accessory is really a refined piece of infrastructure, shaped over time until it became ordinary enough to disappear. A small wire on a desk is part of a system that has evolved for decades to keep billions of devices connected. Even when people never think about it, that system is quietly doing its work. If this video changed the way you think about something as ordinary as a network cable, subscribe to Secrets of Simple Things for more stories hidden inside the objects and systems we use every day without really noticing. And if there is another familiar thing you have seen countless times but never stopped to question, leave it in the comments below. It might become the next story we explore together.